All right, hello everyone. My name is Kelly Chang. I will be teaching for Intro to Python, although I don't know how intro this will actually be, so you guys can give me a gauge. I'll go as basic as you want or as high level as you want, but feel free to interrupt me at any point in time and feel free to ask questions. I do not mind at all. All right, including people on Zoom. I do want to say that you can just feel free to unmute yourself because of the way I have to share my screen. I can't actually see you guys, so just unmute yourself and just shout out the question if you could. Thank you so much. All right. So just to start off, how many people have coded a little bit nowadays? Hands up. All right, excellent. Everyone's hand has gone up. How much would you say you feel particularly comfortable in coding in Python, or are we still sort of just getting to know it and getting to learn and feel it out? Awesome. Head nods. Excellent. Okay, so hopefully that means we're in the right place. Otherwise, if you feel more comfortable than that, please head over to the other auditorium. Okay. So first things first, hopefully everyone's gotten access to our Jupyter Hub. This is my instance currently loaded up, and that's what you guys are seeing on screen. Feel free to load this up, and you're welcome to code along if you want to. I do want to give you a little bit of a layout of what this is. So at the basic level, essentially, this is a Jupyter server that's being hosted by NeuroHack, and you will be able to log in, even if it logs you out. This is your instance. These are your files. Other people will not be able to have access to them unless you choose to share it. And some of these folders that you automatically see here on the web file browser over here on the left is automatically populated by us from NeuroHack to you. So you already saw some of the shared items today. So some of the some of the docs, such as the Zoom links, get set up and scheduled. These are also here for you. They'll be here every time you load it up. But also there'll be a curriculum page, a curriculum folder as well. And this will get populated throughout the rest of the week. And so sometimes if you don't see something, you may need to just repopulate your instance. So if you guys opened up your cloud instance too early today, you might not see my last name here, Chang, Python intro, but that's where all of my notebooks are stored. You guys can have them and you can hold them. Basically, I hopefully numbered them for you so you can go through them at your leisure. These include not only the coding portions, but also some text around it so you can have it and read it slower later if you feel like my talking speed is too fast, or if I spoke something, I misspoke, and you can read through this at a much leisurely pace. But you can have and hold this, and you're welcome to essentially read through it as I sort of type. But personally, I prefer to type as I code, so instead of just reading from the notepad, we'll sort of code along together. Feel free to do so, feel free not to do so. I won't follow the script exactly, but I will do my best. So hopefully people are also a little bit familiar with Jupyter servers now. Head nods, sort of head. Okay, great. So I'm going to start up a new notebook here. This is just a launcher that opens up whenever I open up my instance. And you can see that this is an untitled with an extension IPy notebook. That's what it's short for. And so let's get started a little bit. So I do want to just speak about from the basics. Essentially, well, first thing you see here, this is a code chunk. So code chunk where we can actually type code. But that's not all Jupyter notebooks can do. You can sort of see that there's a bunch of icons over here on the right-hand side. You can insert more cells below to discretize essentially what you want to run, or if you wanted to actually change this from a code to a markdown, so you want to write text to yourself. And we spoke a little bit about how to run the particular cells. If you're on a Mac, it's Command Enter. If it's on a Windows, it's Control Enter. If you were to run that particular chunk, if this is a text, you'll see that it's a little note to yourself. If you try to run this code chunk that I have my cursor on up here, this is not really code. You'll see that it tries to run it through Python as an interpreter, but it will crash an error because I haven't actually done any coding. I just wanted to make sure that sometimes you might accidentally find yourself toggling back and forth between code and markdown, because there's a lot of shortcuts also in Jupyter notebooks that you might not know about. In this help menu up here, it can show keyboard shortcuts. If I run anything, I do a lot of shortcuts and I sometimes forget to explain it while I'm talking. If you find yourself feeling like I've skipped something, it's probably in here. I'll try to slow myself down and explain it again. But in case you find yourself going back and forth between some weird mode that you don't know about, like debugger mode or running the code mode or markdown, you might have accidentally hit a combination of these shortcuts and gotten yourself somewhere you did not intend to. So just to let you know, that's there for you to have and to hold. Okay, so in our Jupyter notebook, let's get started a little bit, where we can start with essentially the basics of coding, which are variables. Variables, just like in math, are abstract representations, hopefully written in a sensible naming scheme, where you can assign it to be any sort of value. In our basic data types for Python, they're the same across many other coding languages. We have our typical integers, so I'll change this variables to my ints. We have my floats. We're talking about our numeric class from an integer to a floating point, kind of decimal number. We also have my strings, where we have in quotes a string of some sort. Please make sure to close it. Sometimes people ask if it has to be single quote or double quote. Does not matter, just stay consistent. And we also have my Boolean, which is short for true. And please note the capitalization scheme. It's a uppercase T, lowercase everything else, or false, same kind of capitalization scheme. If you come from other coding languages such as R or MATLAB or C or JavaScript, right, you know some of these things are more grammatic. In terms of syntax, there might be small differences here, but we're representing the same kind of data classes. And so the reason why we would like variables is because at the most basic, coding starts off with us for calculation purposes. So especially when we're talking about neuroimaging, we're doing a lot of math. So I'm going to use my float. You can use it in all your traditional calculator reasons. I can multiply. And if I run a cell, this last item that has not been assigned a variable, will print out to me in the console. If I were to comment is also command / for you guys, control / as a shortcut. If you have everything assigned as a variable in the cell and you try to run it, nothing will print, just to indicate if I uncomment something or comment something. I also should just save this as untitled because I have a bad habit of trying to save my script every time I run it. So you have your usual calculator instances. You can multiply, you can divide, you can add. Hopefully this is not groundbreaking or newsbreaking, but this is why we'd like to have variables so that we can do many things with many variables without having to incrementally change them every single time I do this kind of stuff. Not groundbreaking, but it's good to know. As for the string classes, I'm going to move this into a comment. Something to know about Python is that everything in Python is really an object, in which case you might be used to functional-based coding languages where we have a function that performs an action on a variable, but oftentimes there's actually methods buried into data types. And that's more of a Pythonic way of thinking when it comes to object-oriented coding. So for my string, let me also explain. When I talk about functions, I mean things like this built-in function called len, which you could imagine is short for length. If I were to ask you, what's the length of my string? 6. Probably what does that count for? string, 6 letters in my string. This is a function call on the variable my string, versus if I wanted to do something like my string dot upper. This is a method call on the variable my string, inherent to the data class of a character that will then uppercase everything. So note the syntactical difference between a function call versus a method call. They both perform actions, but the way the syntax that we call upon them is a little bit different. Now, how do I know that there is such a thing as a dot upper, or how do I know there's a such thing as a dot len? Google is your best friend. Your AI overlords are also now your best friends. They're pretty good at telling you what's actually built into the Python language. But if you really want to dig into specifically where you can look at types of variables, so right here I'm typing type as a function and then my string, you'll notice that when I hit print, my string tells me that the string variable is a string. If I type in dir, my string, you'll see that it actually lists a bunch of things that are associated with this string class variable. And if I scroll down and squint really, and read slowly, you'll see that there is this upper field that got printed out. That's that upper method that was buried in the string class that you might not have immediately known about, but it's there. We sort of take a look through this list as well. You'll also see some interesting stuff like, replace, potentially replacing string characters with other things, remove prefix, maybe deleting a prefix about my string, right? There's a lot of things that you might think will be associated with a string class variable. And this is all sort of buried in here, associated with this class, data type class. Questions so far? And hopefully I'm not going too quickly. I feel like I'm going quickly because people raised their hand and said I'm sort of familiar with Python. So yes.
Sorry, can you just repeat what was the What was the command to look at the list of, okay, thank you.
dir, dir. And then whatever your variable or item inside, please. And so you might assume that if I do type my int, you'll see that it's a type int. Thankfully, I named my variable sensibly. And then if I do dir my int, you'll actually sort of see that a lot of these methods, there's a shorter list than strings, which is, as you would imagine, fewer things to do with numbers, but they all now more reflect things like, oh, what's my imaginary number out of it, or my numerator, or my real version of this integer. There's more numerical class items. And so this is something to sort of think about when it comes to Python, is that what you can do inherently to a data class or object is tied to the data class. So if it's an int, you can do number things. If it's a string, you can do string things, and so on and so forth. Now, these are just your regular variables and your data type classes. We, of course, have also collections of things. And so this also varies from coding language to coding language. We have our lists with syntax-wise, it's our square brackets. We also have what are known as tuples, which look eerily similar to our lists. And I'll even put in the same numbers, but they'll have different class properties or different kinds of behaviors. So I'm going to run this real quick just so you know I have them. My list has square brackets. Look at it as it's being printed. We have our square brackets. My tuple has parentheses. Now, lists are mutable, and that means that they're able to be changed. I can go my list, append. Basically, I want to append a number, let's say, at the end of this list. And if you notice as well that this nothing has changed, but if I print out my list right here, you can see that this particular line of code has performed the action of appending the number 10 to the end of the list. And you'll sort of see that now when I recall the prints on my list. Now compare this, I'm going to comment this out. Compare this to my tuple. I'm going to try the same thing. I'm going to also try to print it if I can. And you'll see actually, instead of actually being able to append, even though you feel like you should, you'll notice it says attribute error. Tuple object has no attribute append. Meaning if I were to call dir on the tuple, it would not, like, eventually if you scroll down through it, have that append function. And why is that? Well, I said lists are mutable, and the opposite of mutable in coding terms is immutable. So tuples cannot be changed once they're defined. So we can't really add things to it, move things around really. They're really used to be static sort of key objects most of the times. And the reason why I want to make sure you see it is because syntactically they look really similar. And just you might encounter this in public data sets or shared code. They might be expecting some sort of key rather than a mutable list object instead. So something to note about syntax. And so if I wanted to call something from list, in Python, the syntax is for square braces. We are in zero-based indexing, meaning the first item in any sort of list object is starting with 0. And so the first number in my list is 1, and so on and so forth. If I wanted to call a second number, it would be position 1 instead. There are various good reasons for having a zero-based indexing system. I will not expose too much about it, but just know that if you have sometimes are looking for the wrong image slice or something like that, you probably have a one-off number. This happens quite commonly and frequently. You can also, for my tuple, you can call the numbers out as well. Like you can refer and grab them out of the tuple, but if they're in the tuple itself, you can't change it. So you can call things out of it, but you just can't put things into it or change it after it's been defined. If you want to grab more than just one number, we can slice. And so let's go from the first position to the second number. And basically with that colon in between, you can go from 0, 1 to 2. 0, 1, and then not including 2. So the right-hand side is not inclusive. So grabbing more than one number from the list. These are your usual like vector-like objects or series of things. Does it have to all be numbers? No, not really. My character. Let me just actually print the whole thing. Right, it doesn't have to all be, some coding languages require your list items to all have the same kind of data class. In Python, you're not required to have it be that way. You can have numbers, floats, booleans, whatever you want, all mixed in there. So be careful. Okay. Next, we also have another data class called a dictionary. And please note that I am using curly braces. We've gone through our square brackets, our parentheses, now to our curly braces. Dictionaries are really nice because there's a key to value lookup. So the key typically, doesn't have to be, a string character. And then the value can be sort of whatever else. It could be a list of items. It could be another dictionary. Your value item in this kind of setup can be sort of whatever. But you do need to have this kind of pairing where there's a key to some sort of value separated by a colon here. Let me just give you like key to. So some other item here. I'll do like, wow, a string. Run this so you can print it to see as how this changes. And you can sort of see there's those squiggly braces, and you have a key to any sort of value pairing. How do I refer to things out of my dictionary? You refer to it by the key. Please note the square braces to index into the dictionary. And specifically, if you call the key, it'll pull out the value. And like I mentioned before, does it have to be a string? It's just commonly a string. I could actually even have this be an integer. Wow, an int as a key. Why would you mix up different kinds of data classes in order to call things out of a dictionary? I don't know, but you can. You can also do tuples. Dun-dun. A tuple key. You can do a lot of things with dictionaries. They're free to sort of mess around with. Showing you this more as for syntactical, wow, even I can't do it in one fell swoop. You can also call it from a key being a tuple. Please note the parentheses here, and you can also call it from a tuple key. You can see its uses. You can see it's sort of like very complex, but just sort of showing you in terms of this kind of data class, you can do a lot of things with it. Currently just taking a look at the things I want to make sure I say. Anything so far? Any questions, comments, concerns? Okay. Also, something about dictionaries that will sort of segue into some of the more packaged versions of how we can organize our data. Try not to double nest. Try not to. You can. Another value. Look at all the syntax problems I'm having. You can actually also nest in a dictionary in your dictionary, right? You can go as deep as you want, and it could be as complex as you want. But in order to get all the good stuff out of there, you're going to have to start stringing things together. The double, then another. That's right. It's just chain it up, and in order to get to the value that you actually want. So just be careful. It could get quite deep and complicated. But if you need to pull stuff out, you can start pulling things out one level at a time. Okay, excellent. Next, on to control structures. Every single coding language has some sort of like if statement, control, if for statement, that kind of thing. In Python, it's fairly syntax rigid. So meaning that if I have an if statement, so if I'm going to write in English first, condition is true. So starting off with the if as the indicator field here, and then what I have here highlighted in terms of condition is true, it could be anything. Like, is my int greater than 0, right? At some sort of test condition for a numeric. If I go back up, I remember defining my int to be 1. Cool, I do have a good memory. And so if I were to run this, this would evaluate to be 1 greater than 0, question mark, it would be true. And so if you hit enter from there, Python automatically helps you indent. You'll sort of notice that this was automatically given to me. This is required. Not all coding languages requires an indent if you come from some other language, but in Python, this is pretty strict. So I'm actually going to do a really simple thing, a really simple command. So I'll print my int just to sort of show you that I managed to hit this condition. And so I am going to execute my print. I also wanted to do this so that you can see if I unindent this, and I did the shortcut command left square brace, that's the quick unindent. Command right square brace will indent to the right. If I try this, you'll get a indentation error. Expected an indent after the block if statement on line 1. So it actually is a syntactical error if there are no indents in the correct levels and positions. So put a tab right there. Goes back to having that as my if statement. How do we chain this up? Sometimes we have another condition. So that was some coding languages call it else if. Python shorts it to elif, short for else if. my float was less than 5. I think I put it as 3, so print my float. And if I were to, before I run this, the chain of logic would be, first it goes through the logic branch where it checks my int if it's greater than 0 and printing my int. Next, if that fails, will it go to my float is less than 5 to print my float? So what do you think will print if I were to run this? Reminding you that my int equals 1, and then my float, comment please, my float equals 3.14. What's the logic here? What would happen first? Yeah, right? If it finds the first true, it does not execute the rest of the block. So if I change this to less than 0, this will evaluate to false. And so hopefully my float of 3 is less than 5. It'll print the float. And then the last chain on here is you don't need every single one of these conditions, but you also have your final one, which is else. Meaning if all else fails, you'll print we're here. So if everything fails, then we will actually end up in the else bucket. Do you always have to have an else with your if statement? No. You do always need an elif with your if statement? No. You can use as many or as few as you want. You can actually have many more elifs, giving you sort of a verbal. I love how it wants to indent for me. It gives you a little verbal, has however many that you wish to go through. I'm going to comment this out and then realize that I want to do this greater than to make it false. And then we're in that else statement right there. If I comment out this else, nothing will print because there is no else statement in my if statement now, right? You don't always need the else, but if you do have it, this will be forced to run if everything else evaluates to be false. All right, awesome. Next is a for loop. So let's start with another list here. So 2, 4, 6, 8, just so we have something nice to visually to go through. For loops in Python are actually really nice. So for item, or let's just say, yeah, item is shorter, in my list is the way you can start. So for the iterative variable in the variable that can be iterated over, I'm going to just say print item. And what this is going to do is print every single item, so every single number inside my list. Yay. It doesn't need to actually specify. If you're familiar with other coding languages, you don't actually need to specify the index position of the listed items, which is a speed saver. But you can immediately, if you have a list that is meant to be gone through sequentially, this is a shorthand notation. But if you are trying to map on to your understanding from other languages of how to iterate over an index, you can do for, I'm going to do I because I'm lazy, in range of length of my list. Give a moment to think about that. So length of my list, there's 4 numbers. Range is a function that you may or may not have seen before, but basically it tells me to go through 0, 1, 2, 3, 4 not included. And so when I print I, you'll see that it goes through 0, 1, 2, 3. So every single position. And people, if they were going to go through an iterative item, would do an indexing version of this. So instead of just going through item, you can go through my list, but the iterative instead, and you'll get the same result. And I realize I should probably just type in both. So give me a second. Print item. These will achieve exactly the same result from the same requested sequence. So 2, 4, 6, 8, 2, 4, 6, 8. So you can choose to iterate over the items themselves, or you can choose to iterate over the position of the items and then call the item. There's also another one. I've noticed how there's many ways to do many things, where we can have I and item at the same time. Enumerate my list. This particular, and this is where we have a little bit of syntactic sugar going on here, where in Python, you can actually package up multiple outputs from a function call. So enumerate will basically wrap up my list with its iterative. And so let's get a little fancy here. Print I and then comma item. So it'll be the position number and then the actual item right next to each other with a space. And you can sort of see down here that this is another option for you to go through a listed item set. Now I'm getting both the item itself as well as the index. And while I'm here and being fancy, we might as well as do as a formatted string. Basically, think of it as wherever I input in my variable with these curly braces, I can then format the rest of the string for a nicer output. So instead of just printing out the index number and also the number in the item, I'm actually going to now format the print so that I'll have the position separated by a period and then the actual number itself. I'll hit run, and you'll notice that that is the difference between our print here. I'm also going to put in the word position, just so we don't forget what that is. So multiple ways to iterate through any sort of listed item. Pick your choice. You can have all or none. You want an index, you want the item, here you go. Questions, comments, concerns, or if I typed too quickly? Okay, good. Now, this is sort of the power of where we can have different data types doing different things. The last kind of for loop I sort of want to show you is for key, comma, value in my items. Right, so I'm just going to put this as a placeholder so it doesn't yell at me to indent. For dictionaries, they're actually also iterative items. It's just that there's no set position, right? If I scroll back up to my dictionary from before where we had key and then this list, key 2, wow, a string, this key that is actually an integer 1 and then a tuple and then another dictionary string. There's no order to this, but there are items in here. So you can iterate through a dictionary as well. And one of the ways you can do that is by calling my dictionary dot items as the method. This will force the dictionary to iterate by producing the key and value every single time. And so you get both of those things. So if you want both, you can also get both. By print, you can sort of see the outputs from the dictionary defined above this way as well. So it's a quick way to loop through dictionaries. And you can do conditional statements on ifs or other for loops on your key, based on your key and then your values. Hopefully that part makes sense as well. Awesome. Taking a quick look through my notes. Okay. Last thing I want to define for you guys is functions. So the syntax for defining a function is starting with def, short for define, my func, and then we have parentheses, colon, and then you'll see the auto indent in here as well. Nothing too fancy about my function. I'm just going to print this is my function. So if I run this, you'll notice that nothing happens. That's because I haven't called on my function yet. So I'm actually going to do a function call here as the last input on my cell. And so you'll see the output. This is my function. We can slowly make this more and more complicated by giving it arguments that it would expect. So let's pretend that I want an X argument. I don't know, maybe a number or something like that. If I were to try to run this cell and try to call the function, this would produce an error. And immediately it'll be type error. My func missing one required positional argument, X. And you can see by the definition that this is a required argument. It expects this number and it cannot run without it. We can have default arguments, meaning optional arguments. So let's say I want my X to be a 1 by default, even if I don't provide it. So you can just specify in the function definition itself by giving it a default value. So when I run this now, it won't throw an error, but I'm not doing anything with the X inside the function, right? But it won't at least throw an error. I'll just add another print call that says X formatted X equals. I need to get rid of this. This is my function print. And so now when I call my function, even without specifying an X value, it'll print automatically. This is my X value is 1 as a default. If I wanted to specify something different, I can go X equals 2 in my actual function call. Any user-given argument will overwrite the default, and you'll see that the X has now become 2. Or anything else. Can I keep on adding arguments? Of course I can. But once you define an optional argument, it's going to start yelling at you because we can't have optional first and then required. The order of operations is required first, then optional. So if I try to run this, you'll see that it's a syntax error. Python's errors are pretty informative if you sort of understand what's happening here. It says syntax error, non-default argument follows default argument, meaning a required argument follows an optional argument. So your order of operations is a little bit iffy here. Let's get rid of the optional part. And it's now my func's missing one required positional argument, right? So now we have two of them. Let's give it another. It's 4. All right, everything's looking nice. So basically, in a function definition, if something is not defined with an equal signs, it means it's required. You don't have to specify it in the order if you also specify the argument name. So if I do y first, y equals 4 first, and 4x equals 2 seconds, it's okay, so long as you've defined it. But if you've done something like this, my func 4, 2, and it was expecting y to be 4, let me comment that out. It will go based on position, right? You've given it no information about what argument this is, it'll go based off position. The reason why this is sort of interesting and important to know is that the next thing I'm going to speak about is packages, is that as we go over to, and Python itself, when it's base Python, is not that powerful. There's things you can do. You can calculate, you can do your string operations, make things lowercase, uppercase, do true, false statements, if, ors. Those are all good. But the power of Python is that you don't have to rewrite the wheel from scratch. You don't have to rewrite matrix math from scratch. You don't have to rewrite calculating row sums from math from scratch. That would be a laborious project, which is why people have already done it for you. And so the power of Python is the fact that there's a really large community on this open source coding on the internet. People have written stuff, people have spent a lot of time developing stuff, testing stuff, deploying it to GitHub, and having it be scraped by our AI overlords, willingly or not. So everything is there. But when you look at documentation, let's say for this package called NumPy, let's go to API reference. Let's go to something that I might recognize or I should search for. Please give me a function, please. API reference, modular structure. Wow, maybe I should just hit on like random. Please pull up what I'm hoping you pull up. We're struggling here with the internet. Why? Okay, here we go. Haha. Something as innocuous as numpy.size. So from the package numpy, which I'll speak about in a second, we get this function called size. And you'll notice that people, when they write documentation, write it according to Python's like required in position arguments, and then your optional arguments with their defaults. So sometimes if you use something from someone else and you don't know what the defaults are, or they don't specify every single argument, a really good way to go look for the default is just to pull up the documentation and read what they specify as defaults. So this will be, and you can sort of see that in NumPy, they really do adhere to a lot of the way Python expects their arguments and their definitions as written, mirroring on their documentation. Okay. Questions, comments, concerns? I really sped through that. Possibly the fastest I've ever sped through that. And every time I've taught this. Most of the times I sometimes slow down for this, but these days, because we have really good, like when you Google things, it's like, what is a string data type in Python? I do want you to note that I will typo, but also that one of the things about Python, as mentioned before, is that it's so popular and readily available on the internet. And even Google's AI will immediately tell you about immutable characteristics about the string. Can it be indexed? Is there a no character type? Like, so if it's a one character string or a multi-character string, it'll even give you examples of doing it 1 line, 2 lines. Notice how it also you can use single or double quotes. You can also use triple quotes for multi-line. Your AI overlords can answer a lot of really good questions. But hopefully what I'm giving you here at least is the terminology to query your AI overlords about how to go search for the question. Somewhere to start so that you can then sort of build off that. So notice that here's literally the F strings, the formatted strings I just sort of explained to you guys. There it is as well, giving you as an example. So don't be scared to just ask and look online to see what happens. Nothing's going to break if you do that. Nothing's going to explode if you try something and it doesn't work. Just try to use it with an informed mindset that sometimes it could be right. Probably most of the times it will be right, but sometimes it might be wrong, especially as we go more and more into these lesser developed packages or places or data sets that the AI overlords have not scraped to kingdom come just yet. Okay. So, any questions? Yes.
Does space matter?
No, it does not. Not really. I can do this and everything is all good. I'm just deleting spaces, all hunky-dory. Indents matter. Indents really do matter. But spaces not really. I prefer spaces because I read English hopefully relatively well with spaces in my view, so I tend to overspace stuff. If you don't want to, you don't have to. This is my personal preference. Okay. On to packages. So how do we import other people's functions or functionality into ours? Well, thankfully, in our little server here, we have a lot of our basic packages installed. We can just call import, name of the package. And then if you want a shorthand for that package, so import numpy, that package I just showed you, as np. So every subsequent call, we don't have to keep on typing numpy. We can just type np. Some packages, especially for the really well-developed ones, there is a sort of, the shorthand is so commonly used, I would say it would be very dramatic if I called it anything else. So when I read NumPy code, I do expect NP, yada, yada, so on and so forth. Okay, nothing crashed. That means I do have the package. Excellent. So the thing about NumPy is that if anybody comes from MATLAB, you can sort of know that making matrices in MATLAB is really easy. You also will sort of be defining matrices in MATLAB by default. However, as you sort of saw from like the list convention here, that's not really the default in base Python. So if I wanted to make a matrix, so like my matrix in Python, you're going to have to watch me do a little bit of creative spacing here. First row, second row. And you'll sort of notice that it's actually a list of a list if I were to actually look at this thing. So this first outer square brace calls my whole list. This first row that I'm typing with indents to make it readable is the first row, and this is the second row. But if I were to call on this just to print it out without having to define it, this is how it prints out. List one, list two, everything's flat. And you might be saying, oh gosh, what if I want to query the length of this thing? Well, there's only two. What is that? Oh, that's how many lists are in my lists. And that's, okay, your row count, sure, but that's not super informative. Usually with our matrices, especially our 2D matrices, we want the row and column. So how do we get that? Well, people thought of this problem and people said lists of lists are sort of dumb when we want to talk about like 2D representations of numbers. And so let's call np.array. So instead of having a list of a list, numpy.array or np.array turns this list of lists into a numpy nd array. And so let me actually call on it and you'll sort of see. Note that the print syntax is different. That's because numpy automatically inside this call now defines this particular matrix variable as an nd array. And so it'll have different print outputs as a default. So previously you saw the list flat. Now in this nd array, it's trying its best to make something that's 2D like. That makes it a bit more numerical for your usage. We can also type, still the same function from before, and we can query it. So instead of having a list of lists before, sorry, I should also do like type my list from above just to show you that they will print differently. So if it's a list, it'll tell you it's a list. If it's an nd array, it'll say numpy nd array. So the data class object type has actually changed as well. And what I said before about everything in Python being an object, that means it also has a list of different attributes or methods associated with it beyond the ones that were already built in. And we can check that too. So dir my matrix, and you already sort of see that there's a lot more stuff in here. If I scroll, you don't need to like squint and read too deeply, but you can sort of see there's a lot more stuff. Dot, maybe for dot product, D type for data type class, flat, flatten, max, mean, min. All of these math functions that we really like and want to use without having to think about it. It's sort of built into the class object or the data type itself. Can you, oh, yes, is that a hand? The underscores, these guys right here. So these are a special type of attribute. In Python, there's no such thing as a really private sort of attribute. So in some coding languages, there are some things that a user cannot access. In Python, everything is accessible. So this underscore convention is just to tell other users that Don't touch.
Doesn't.
But you can touch. Yeah, you can still, yeah. You can still add on top. You can actually overwrite these too as well, from what other people have written. It's just a convention to say, please don't touch, or try not to touch. Great question. Yes.
Alright, just to clarify, so these, the underscore surrounded ones, like you can still go in and modify them, but they just don't want you to, the ones that don't have it, like.
Yes.
Something you could go and mess around with.
Yeah, so these are known as sort of built-in. So let me take a small detour. These are excellent questions. So let me define my func as again, prints function. So this is a user-defined my function. Let me do a real quick check on the type, my func function. Let me do a quick check on the dir. It comes with, when you automatically create functions in Python, it automatically comes with these underscores. When I'm defining the class of my function, I can actually, don't actually do this. This is a little bit different. You can actually define something like this and change it. Changed, private function. This is not the actual way to do it, but if you were to write something like a class, so instead of a function, a class, my class, instead, you can actually change what the underlying underscore stuff does. So can you modify anything you want? Yes, you can. And actually in NumPy, they do. They do changes to these default attributes so that it does math on the matrices that you would expect you would do matrix math on. By default, they do vectorized math. So like 1 + 2 is 3. But if you do like 3 times a matrix, right, you want to scale all the elements in the matrix. They're changing something about the inherent property of that data type to get that to happen. Great question. Yeah.
Do all these packages need to be installed individually, or are there libraries or something standard?
Excellent question. So a lot of these scientific computing software packages, at least here, they're already pre-installed for you. But if you wanted to continue to add new installs of other packages that we did not install for you, you can go back over here to the launcher. So all I did was add a new tab here. I'm going to pop open the terminal. And you can sort of see that this is, sorry, I should back up a step. Does everyone know what a terminal is? Okay, head nods, great, yay. So over here, we're in actually a conda environment. You can sort of tell because here at this first line of the terminal, we have this parentheses notebook. So this is a conda environment where we've done basically installed some of the other stuff for you. You can basically do pip install, and then name of the package according to however they spell it. I'm just going to reinstall NumPy because why not? Yay, it looks like requirement already satisfied. If it wasn't already satisfied, I can do upgrade. So if I wanted a newer version of NumPy, please don't crash anything. I'm going to click it and it's going to download it for you. And then it's going to be able to install it. You can sort of see it's doing its routine right now. Please ignore some of this other stuff. We are trying to control our versions here. But essentially, you can also install whatever else package you want. So let me say if I wanted to install, I know there's a package called Seaborn. Let's install it. Looks like it's already in there. Excellent. You can install it there. And then when you go back to your notebook and you run it, it should be there for you. That's the asterisk right here says it's thinking. Maybe I didn't install it. Oh no, did I crash my NumPy? I should not have done this. I did. No, the versioning. Existing installation. I'm going to go back. Pip install NumPy. Correct version. I should not have upgraded. So welcome to versioning hell. Please, if you encounter this, come to one of us and don't break your NumPy.
If you do this on accident, you ruin your versions. You can just stop your server and restart your server and you'll get the original server back. So your home directory is saved like your data, but the installation will get reset.
I'm going to see if I can save it with a restart. Don't do that. So, fun fact about NumPy from like 1 point whatever to 2 point whatever, there was a really big change in the underlying functionality and argument calls for it. So you're welcome. This is actually a great learning experience. I've saved it. Yes. Installing the correct version will always do something good for you. But yes, you can install anything you want on here. If you want to talk more about packages or other interesting neuroimaging packages, feel free to talk to any one of us afterwards. Okay, where was I? We're in data types for NumPy arrays. And so you could imagine it's like, wow, someone was really, really thoughtful and they made basically a matrix package for me. They basically did. Because like if you try to do my list plus, let me print for you my list again. Ooh, I restarted, so nothing's here. Great moment to talk about all these other buttons up here. If I hit this play button, this will run one cell and move forward. Stop will halt any sort of execution if it's taking too long. This restart button literally restarts the whole thing, wipes it all clean, clears all your variables. And this fast forward button is go through everything. So I'm going to click that real quick and hopefully have it run through. And you can see the asterisks all pinged up at the same time. First one in, second one, third one, so on and so forth. We're just going to go down here. Hopefully I didn't leave an error in here. We did not. Excellent. So we're back with that in my list. If I try to do math on this, you get errors, right? It's not like Python base-wise knows that this list will need to have every single element add 1 to it. It's not a mathematical object because my list could have also had characters in it. What is it going to do in that case? So in this scenario, when we have a my matrix and we do a my matrix plus 1, all elements in my matrix got an add 1. Sorry for the print sort of squeezing up a little there. So it knows what to do when you want to do math on things that are not a single number. And that's sort of the power of data types and knowing what data types you can and do what kind of behavior those data types will perform when you perform things that you expect especially for mathematical operations. So moving down just so we can get a bit more space to see their output, my matrix, and you saw something like a mean previously before. Ooh, where's this 3 coming from? My best guess is if I go to numpy.mean, look at the documentation, first thing to pop up, cool. And you notice that there's also in this documentation immediately many more arguments. I should switch to the stable version. Many more arguments that I did not even specify, but it was able to call. Even without this A, it actually sort of understands I am trying to compute on the object I'm currently indicated on, but I didn't specify something like axis. I didn't specify anything like D type. Well, what are those things? Let's just read. Axis or axes along which the means are computed. The default is to compute the mean on the flattened array. Oh, so that 3 is from the entire matrix as a whole, all elements averaged. Let's say I only wanted the row average. That'll be for axis, the first dimension of representation, and you'll get 4 numbers out. Well, looks like that is actually my column sum. Whoopsie doodle. And sorry, column mean. And then if I do axis equal 1, okay, there we go. There is my row average, matching it to the number and the shape of my matrix. Speaking of shape, so you have your mean, median, max, min, standard deviation, all those good usual calculations in there. Other kinds of things that don't require a parentheses, so not a method call, but actually an attribute. Things like shape will tell you the shape. So rows to columns, 2 rows, 4 columns. Notice that the call on this one doesn't have parentheses on it. So I'm actually querying just sort of an information about that particular matrix. I'm not doing anything with it. I'm getting it back. Please also note that what kind of data type is this? It's a tuple. This matrix should not be changing its data type if you haven't messed with it yet. So, right, it's immutable in that sense. So you'll see this and encounter this in various kinds of packages elsewhere in the world. You might think you want to put it as list. You're not wrong to do so, but in this case, someone thought, oh, a matrix is defined with a particular shape upon definition. That's an immutable property of that particular object. Yes?
Coerce the tuple to the list or back.
Yes, you can. Yes, you can. Very good. You can coerce between types. So if you call on functions, this is a base function called list. I'm doing it on my tuple that I defined earlier. Well, there it becomes a list, but it's not actually still that tuple object. You can go call it back. So let's just say copied tuple as list. Don't type this variable name. It's so long. Why did I do this? To show you that tab will autocomplete for me. And so let's do that real quick. And then let's see if I can do tuple. Copy, paste. Ta-da. You can go back and forth, but note that you can't actually append to the tuple. You have to convert it or coerce it to a different type and then modify it and coerce it back. So there's properties like that sprinkled throughout Python to just be careful about. You can overwrite things, so like dictionaries as well. You can just copy. So I have my dict has, let me actually also show you, you can print the keys right here. Okay, cool. I have a key called key. Let me just overwrite it, overwritten. Print. And it's also been overwritten. So you can overwrite things as well, or you can replace things as well. So dictionaries are not immutable, but this tuple right here is immutable. So within the discretized data types chunks, some things can be moved, some things cannot be moved. Yeah, what's up? Mm-hmm.
Where your input automatically converted into float, and you were able to calculate them.
Yes, it does. So my ND array, if I go back to NumPy ND array, let's look up the documentation. Once again, spelling it correctly. If you notice that there's an argument that I did not specify upon call called dtype. So this is short for data type. And if you notice here, it says np.float64, automatic conversion. Automatic conversion upon call. So it's actually calling this dtype equals np.float64. So it's actually making my matrix to the units of float64. Let me just print out the matrix again. I'm enjoying the blank. Let me see if I can force it. No. Don't know why, so we're just gonna restart. Thankfully, I only did math, so hopefully nothing's too bad. Nope, it just hates me. We're gonna drag it. There we go. So there we go. We have the float64. You can also see sort of a visual indicator here. There's a dot that sort of indicates it. I can also change it to 32. You'll start to see more information as it floats in. Ints, let me just actually detype int. Now you'll also see the change there too. There's no more floating point in the output. Yes.
Say you wanted to apply some standard mathematical transform, is there a good way of searching packages to see if that particular operation has one?
Excellent. Yes, the first stop is NumPy. Most stop mathematical operations are in there. If it's not in like np dot like math function, it might be in np dot linear algebra dot. So there's sub packages inside NumPy. Here is a very good reference point. So NumPy has many ways to call it. NP for the base NumPy stuff. And then there's more fun stuff like np dot linalg. So you have to do 2 dots. And then linalg itself has like matrix multiply. Matrix mult, I think, is the actual function name. Basically, the subnaming here is just to try to keep organized. Like they're trying to go base NumPy has mean, min, max, all the good stuff. Linear algebra or like polynomial has then like norm, 2, or something like that. Like more specific to that kind of math. But they're usually in here. That's your first pass. Your second pass probably is going to be SciPy. Short for scientific Python computing, I think. And then so in SciPy, there's some more statistical functions in here. There is some clustering, some Fourier transform, if you sort of see here. Let me make this bigger. SciPy.fft, so Fourier transforms are in here. Integrations, interpolations. If you don't see it in NumPy, it's probably in SciPy. If it's not there, it's probably in another package that calls another package. At that point, I would Google. I would start going like, is there a package for like image convolutions? Yeah, probably. Is it probably a sub package somewhere? Yeah, probably. Some of the really big names have very iconic names packages. So there usually is the word pi in them. If I see the word pi in it, I usually trust it, which is a bad comment, but you know, you can always ask one of us if we've used it before. Sometimes if you're really like looking on someone's GitHub page for like a really crazy function, we may want to test that first before we actually go in, because you can install it and you can use it, but we may want to test that first before we use it.
One of the great things about the advent of large language models and the prevalence of Python is that for pretty much any mathematical transformation you can think of, if you ask a large language model, it will probably tell you where to find it in Python. But kind of what Kelly's saying, if it's a NumPy or SciPy, you can almost certainly trust it. If it's from Joe Schmo's GitHub repository, you may not want to just trust it. So
the meme of was like, he built this out of a box of scraps from Iron Man. That's how I feel sometimes about some of these. So like sklearn, scikit-learn is also a really great package. If you also, so you can see some things like here, like covariance matrices, some feature selection, feature extraction, Gaussian processes, right? All names, terminology you've seen before. Maybe you don't know exact implementation, but I do trust this package too. So these top 3, these are my top 3. If the math is not in here, let's talk about it before we start installing random things we find on GitHub. Okay. Great, great, great. Okay. Give you a second to look over what I have listed down here. Great, great. The last thing I'll sort of leave you with about some of this matrix stuff is make sure, just as in actual matrix math, rows to columns. It's always rows to columns first, or at least however many dimensions of your matrix you want. So specify, I want the first number in the first row, first column. You can start to chain up your dimensions of calls. It's not just one number anymore. It's now you can chain up as many as you want. I'm also going to populate a random matrix. My matrix equals MP zeros of a random shape, just so I can sort of show you the shape of this thing. So print my matrix. Right, sorry. I needed to give it a tuple, not a 5,6. I also need to spell matrix correctly. And just populating a matrix filled with different zeros, just so you can see the shape. It doesn't have to just be 2D. If we're thinking about MRI images, we also have 3D. Look at this print. Not so great, but you can sort of understand that it's 3D. What about 4D? Most definitely, but now we're getting really crazy. I can't really interpret the output, but you can sort of see that it is there. I don't often print the matrix anymore. Usually I print the shape of it. And you can sort of see correspondingly, it gets just 1D, 2D, 3D, ND, all the way up. You specify what part of the matrix you want based on how many dimensions you want to go for it. If I wanted to specify all of the dimensions, so first row, first column, first slice, and then anything in that fourth dimension, you can sort of see it's like, okay, here we go. We can start to extract it out. If I wanted more than just that, I can also still slice along any of these dimensions, again with that colon as well. And you can sort of notice, you can keep on chaining these up as far as you go. Yes, was that a hand? It does have, yeah, it does as well. You can also do that. This is another kind of data type coercion kind of thing. You can also do math on strings. Just be careful if you accidentally do that. Strings are actually represented as byte integers inside Python. So if you do math, you will get math. Just be careful, but it does represent strings as well. Most of the times though, we talk mostly about it in terms of numbers though.
Not sure that's, so.
Is it not?
I believe if you multiply a string by a number, it will give you that many copies of the string. So
Yes.
String times 2, yeah, string.
Yeah.
It does the same thing with lists, actually. So if you give it a list and say times 3, it'll give you 3 copies of the list. You can put it together. Some of this has changed fairly recently, actually, because of the
Because of the 2.0.
Yeah, there's been some recent updates to the way Python handles string because, man, this is a long story, but there's the ways we used to handle strings where we just treated them like bytes, and that is really bad because a lot of languages don't have more characters than there are bytes. And so at some point in the last 10 years or so, there was a big rewrite of a lot of programming languages to use what's called Unicode, which lets you store complicated characters that are not just A, B, C, D, etc. In byte or in strings. And so now Python string or Unicode, this is like way too much detail. We don't really care about this for this for the most part, but that's what Kelly's running into.
Sorry, I think if you learn R is still actually that way. So you can actually still add strings together. So my bad. That's must be a new update. But Noah's right. If you do math on strings, it's not like it'll give you an error. So this stuff like this, string times 2. So I'll give it a space for you. So it's just multiplying the string twice.
Yeah, I think you can add strings to concatenate 2, I think.
I think so. String plus high. Hey, look at that. Yeah, you can. Be careful. I just know in like some other coding languages, you add like a character or a Unicode, like a small enough character, it'll be like 1 + 5 = 21. You're like, where did that come from? So just be careful, be mindful. Okay, great questions. Another package that you might want to use if it's not just for numeric stuff is pandas. So import pandas as PD, another very canonical kind of shorthand for pandas. Pandas, if NumPy is for your list of lists to get matrices under controls, pandas is get your dictionaries under control, essentially. So I had that, which was also not the world's best dictionary. It's got like crazy amounts of keys and different kinds of data classes. It also has dictionaries on dictionaries. You can sort of think of pandas as your CSV files or your Excel spreadsheet files. So the key to value does make sense, but it shouldn't be this many different data types inside the dictionary. So let's make something a little bit more sensible. So this is like column A, and this has 1, 2, 3, 4, column B, and then 4, 5, 6, 7. And then we want to close it the same way, starting off with my dictionary. But what we can do instead is convert this similar to how we converted that list of lists to a NumPy array. We can convert it to a data frame. Please note the capitalization. If you're going to ask me how people decide what camel case, uppercase, sentence case they use, this is a personal preference, and we are just living in their worlds of how they define their dictionaries. So you sometimes, if you spell something like all lowercase data frame, you're not wrong. Someone out there has also written something like that. Just sort of notice that these things change depending on the package you're using. Let me feed in my dictionary. I will also really quickly, before I do that, print the dictionary just to give you a reminder of what the output looks like when it's a native Python dictionary. Once you convert it into a pandas data frame, please note the really nice formatting. And that's because it knows it's a panda data frame, and so it'll try to print really pretty like this. You'll notice that there's font coloring, index coloring, right? All the good stuff that you don't want to think about and you just want to see. And this is because, as someone mentioned before, there is an underscore, I think print or something like that. Someone rewrote that print private function to do this for you. So that's sort of the power of object-oriented coding in this case. Okay, so you don't want to make dictionaries like this. This will be laborious and very difficult. And I also don't like it because I don't want to type that much. Let me go down here. We have a much more useful pandas read underscore CSV. If you are where I am in this current folder, in curriculum under Chang Python intro, there was a little data folder. There's some CSV files in here for you to have and to hold and to play with. I'm just going to load one of these in. So I'm going to start from where I am, go into curriculum, go into Chang, go into data. Let's just load in subjects.csv. So I specified the function read underscore CSV, and I'm going to give it a data frame class and read. Great, didn't crash. I pathed correctly. If you don't want to type all that out, or you're very prone to typoing like I am, I basically tabbed completed all of that sort for you. So you start off with the dot that indicates where you currently are, / and then you can sort of type C and then tab. It'll try its best to auto-complete for you, and so you don't have to type all this out. I'll navigate back to where I originally was, just so you guys know where I am. And I'll give you guys a moment if you wanted to type that. Okay. So just like before, Panda Data Frames also has really good attributes and really good methods buried in here. Sometimes you don't want to look at the whole entire data frame. So if I try to print the whole data frame, it'll do its best. It'll do some ... dots just so you don't have to see the whole thing in one fell swoop. But sometimes I just want to make sure I have the headers I want. I just want to see the data's loaded in correctly. I can just do .head parentheses, and it'll give me the top 5 rows here. And you can also see the column names as well. So that's really useful. If anyone comes from the land of R, this is where a lot of tidyverse things and panda things will start to mind meld a little together. So there is an equivalent in both lands, just to speak to the people who know about this stuff. It's just syntactically, it's a little bit different. Okay. So something to really understand about Panda data frames is that it has both columns and indices. So columns for obviously column headers, indices, and you can sort of see them in bold here. It's very faint, but check it on your computer. This is basically the row number by default, but it doesn't have to be. So you can also query for this kind of information by asking dataframe.columns. What are my column names? There you go. The unnamed seems to be, I think, the index row. So actually, I think my memory serves me correct. Dang. As index? Cannot remember. Read underscore CSV. Panda.cv. Look at all these defaults. Index call. Index header, yes. Index call. Index call can be forced. Yeah. Index underscore call equals false. Let's try that. True? Darn. I tried.
Thinking it was called there.
Darn, I tried. All right, we give up on that. As you can sort of tell, there's a lot of defaults even I can't remember off the top of my head. I just Google it and read the doc real quick to try to check it out. But some of the things you do want to be able to query really quickly, column names, df.index will sort of tell you basically the row index. So starts from 0, goes to 77. There's 77 rows in this data frame right here. Just sort of more information about your data frame. You also have info. Oops, sorry. Call info. It'll also do a quick summary of all your data, of all your columns, check how many numbers are in there, what kind of data type they are, to give you a quick summary of what's in this data frame. You can also sort of see that it's reading in a lot of floats here for some of our numeric columns for IQ, IQ matrix, IQ mocap. If I remember correctly, this particular data set had basically subjects and their basic demographic information they collected at the time. Think df.describe. Yeah. Also has a different version. Info gives you information about the column, so data types, how many missings, how many NAS, that kind of stuff. Describe now gives you your basic summary statistics based on the columns. And they only do summary statistics of the numeric columns. Age, IQ, IQ matrix, stuff like that. You can have your counts of how many mean, standard deviation, min, and your interquartile ranges.
Is there a way to tell where you are? Like if the tabbing's not working, but like I know in the terminal, you can like see the like whatever directory, but within the Jupyter notebook, is there a way to figure out where you are?
So here's a fun fact about Jupyter notebooks. You can actually use bash commands in the cells as well if you start with it at the exclamation point. So where I am currently is home Jovian. That's where this is right here in my folder. So if you do this right here, you should be able to find out where you currently are. You can also pip install from here if you're really feeling fancy, but we're not going to run that NumPy call again. Yes.
Does the notebook see current workspace assign variables?
Yes.
Run dir by itself.
Yeah. The problem with that is you're not wrong, is that there's a lot of hidden things in already populated to you inside of Jupyter Notebook, but you can sort of see down here all the my underscore stuff. There you are. The problem, gosh darn it. But the problem is there's a lot of private variables that help you iterate, as you can sort of tell here, loading in the session, what the script name is. They're also buried in here when you call dir as well.
There's a tradition in notebook interfaces where they save all of the inputs and outputs that you write at it, like as you go through the cells. They write these variables like _1 that I think stores the input you gave in the first cell you ran or something like that. Or the output,
Yeah.
maybe, I don't remember.
I don't even know.
That's what all that nonsense is.
It's a class of int. Amazing.
There's also the function locals. Which
Oh, yeah, it will also do that. Locals will also give you way more information than you need. As you can sort of tell here, underscore name, underscore main, doc, automatically created module for IPython interactive environment. There's a lot of stuff in here. If you really dig deep into like how Python is made, like as a coding language, this is sort of your little touchstone into it. Please also note, IPython is different than Python. So you'll have other additional built-ins from a notebook, which is interactive. It needs to keep track of a lot of things that you've run, things that you currently are evaluating, versus a Python script like .py. There will be differences between the two. Feel free to talk to us about either one. It's just, that is way out of scope for this one. But yes, here you are. There's also another thing called globals, but we really are not going to talk about that. Okay, great question though. Usually when it comes to notebooks, I will say about checking your local environment, because of the nature of the going back and forth and rewriting, overwriting stuff, I try to think of notebooks as scratch paper. Yes, you can definitely run a lot of powerful things in here. And especially if you make one cell, like do one concrete thing, that's totally fine. If that's how you work, that's great. That's awesome. But I personally treat it like scratch paper. Like I doodle out my ideas and then I'll copy and paste it into a Python script, which is more sequential. And you only can force it to run in one way. Feel free to, again, to talk to about workflow, but Python Notebook is a way better learning tool because it's more interactive and you can overwrite and rewrite things quickly. Doesn't mean to say you can't do your analysis in here. It is also fine to do that. Okay. How do we query items in our pandas data frame? We can do it one of two ways. You can either go naming wise, or you could go index wise. Index, as we know from all of our indexing through matrices, is our like numerical base position indexing. So if I do dot iloc for index localize, and then I do my square brackets again, I want all the rows of the second column. So I'm trying to hit that subject ID column right there. If I hit run on this, yeah, we got it. Right? We can do the traditional localize by index command, but why would we do that when we have things named? Instead of iloc, we can do loc, short for actual localize. So all rows of, let me just make sure I spell subject ID, the named column correctly. Subject, all lowercase, and then ID is capitalized. If we do that, you get the exact same output, but this time specifying it by the actual column name. And so you can do fun things like this with actually the column names by header. Let's just go all the way from subject ID to IQ. Note the syntax is with the colon, similar to how we do the index localizing, but because we're using a pandas data frame, it sort of understands that we're trying to go from named column to named column right there. And what you're returning out, please keep in mind, what you're returning back is not the actual numbers. Because of it's sort of implied by the print, but you're getting back, type, pandas core frame dot data frame. This is a pandas data frame. I actually wanted the numbers or numerical values or possibly even characters out of this. You have another attribute to call out. I believe it's values. And it'll pull it out into a NumPy array. So then you actually have the actual numbers and not the actual data frame with the data frame methods. So there's a little bit of levels of abstraction here. Does pandas also know that if you pull this out and you want to do math on this, they have thought of that. You don't have to pull out the values per se, but if you really wanted to pull it all the way out, you can sort of dig into it and incrementally pull it out. Okay, same as before. Pandas is literally built on top of NumPy, so NumPy is below, then Pandas is on top. So sometimes people who write packages are really smart, and I believe these people are very smart. They'll expose or basically unmask functions that are in NumPy or like the base package into the overarching package. So let's say I have this data frame and I want to just look at my IQs. Let me just scroll down so you guys can see more of it. Let's do loc all rows of IQ to, I think it was IQ vocab underscore vocab. Let's give it a look-see. Hey, look at that. These are the columns I want to do work on. I want to do mean of these columns. Hey, also you can do mean. It's exposing the mean function, and there's a little bit of wrapper on terms of pandas logic where it's like, okay, these are numerical columns. We should probably average over these columns rather than going by rows. Like there's some overarching logic from pandas to do that, rather than from, if you saw before the NumPy mean, it was like, oh, let me flatten the entire array and take the average over the entire matrix. Because there's some logic in the math and matrices to do that rather than this. So, right, even though it's all a mean method, depending on what data type you're in, it'll sort of change the behavior. Doesn't mean you can't access the other behavior. It's just be careful where you are and what you're doing. Okay. And there's, of course, like standard deviation, STD. I do remember some of my basic stats, command calls. Okay. Some more important things that if you want to do actual aggregate numerics or summary statistics on your data frames. So just to show you the head of the data frame again, if you notice, again, I mentioned the index here is in bold on the left-hand side, but that's not a very informative index. And what I can do instead is set the index to be something more meaningful. Let's say the subject ID column. So if I do set underscore index and then give it the subject ID column, I want you guys to sort of take a look to see how the output will change a little. Can anyone tell me what changed? It's a really hard spot. Sorry, second. Yeah, and especially there's a little offset here. Sometimes if you're not paying attention, you won't catch this, but basically the offset here is trying to tell you that this column is an indexing column. If you can see it on your computer screen, but the index column is also bolded as a formatting choice. Yes?
What happens if you have the same subject like
It will yell at you a little. Basically, indexes should be unique in that kind of way. Okay. So row numbers is a very good index as a default because hopefully you have unique rows. So, okay, if you have your data frame now, I'm going to do sub as this one, just so you can sort of see it. Why is it useful to have it as the index? Well, that's because now we can, instead of having to do the loc function, we can literally just go subject underscore underscore, let's say 5. I don't see him on the thing. I forget. Do I have to still do loc? Did I spell it wrong? Do I even have a 5? It's a great question. I mean, just do one I can actually see then. Copy, paste. This is someone else's data set, so forgive me if I can't remember. Let's follow the errors. Key error. I think I do actually have to do.
Yeah.
I think I have to do it that way. Shame. All right. Forget what I said. But you can actually now, instead of specifying the row number, you can actually specify it by the index. So one column having the index is not like the world's most interesting thing. But the reason why is that you'll see this in a second. So there's an even more powerful function called group by, where we're now going to try to group together different columns. And I'm going to put a head over here so I can see which ones I have. Let me scroll down a little. I'm going to try now to group by gender. So I see it as a categorical male-female indication here. And I'm also going to try to group by handedness. Handedness. Giving that to the group by function as a list. I'm going to run this to sort of show you what happens. It doesn't actually do anything. It just sort of returns to you a group by generic data frame group by object. So it's giving me back an object. What we can do with this is actually specify, let's say, a numeric column right here. Please notice the logical chaining. Using my data frame, I'm grouping by gender and handedness. I want to work on the IQ column. Let me just calculate the mean on the IQ column. I'll give you guys a second to sort of digest this really long call. And you can sort of imagine this call getting longer and longer. So hopefully this is enough for one typing session. I hit run. You'll actually see that it is trying to group up gender here, this first one. That's the column that it's indexing by. Handedness, left, right. Looks like there's only right-handed males in this data set, so it didn't even bother with the left-handed. And we got mean of the grouped columns like that. If I also do reset index, it actually gives me back my data frame. And so now here's maybe a summary statistic data frame instead. So you can sort of see the power of pandas. We're organizing your data in this sort of way. You can sort of, again, if people are familiar with tidyverse, it's very similar kind of thought process. We're trying to group up data, trying to do aggregates on different kinds of columns or different summary statistics, or collapse or expand our data sets in a CSV or table-like manner. Now, okay, let's do that set index again, but this time let's do gender and handedness together. Handedness spelling is good. Now can you sort of see what's happening when I do a double index? Again, note the offset, note the bold. It's not actually row numbers anymore. Now we're actually specifying that we can refer to or get data out of this data frame via these female left or female right kind of combinations. So df summary, loc, female, left. Gotta remember. Was there not a left? Gosh darn it. I always forget how to get this. Well, get multi-index out of pandas data frame. Welcome to the AI overlords. Reset level. No, amazing. They don't tell me.
I'm not 100% sure you can do this.
I'm pretty sure you can, but I might just be confident for no reason. Oh, is it double braces?
Right.
Darn. None of index left. Okay. Watch me debug in real time. I'm confident you can do this. Oh, 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 oh. Reassigning your variable will help you greatly. And then it's a tuple. Yeah, my memory's bad. Sorry, let me explain what I just did. I forgot to reassign the DF summary variable. So it was just floating around there without anything. I was printing it for you guys, but my bad. You could not see that you can actually now refer to the female and left column. So notice that we're now specifying it by 2 indices. I see confused faces, so I'm actually going to print it again and show the data out. So when you set index, it doesn't have to just be 1. If you remember, we were trying to grab the subject index, sorry, the subject row by the subject name. That seems all fine and good. It got us our age and gender, handedness, so on and so forth in one call, sort of like up here. DF subject, specify the location, the index, you can grab that. But once we do some group by, you can actually have multiple categories of indices. And in this case, because I did a group by gender and handedness, we're now collapsing our categories. And now we have a double category, right? How many females, what's the mean IQ of females who are left-handed? And that is actually a double index, or what's known as a multi-index in pandas. And if I want to grab that out of the summary here, I can now specify it with a tuple, female, comma left. Instead of having to go like, okay, where is the female? Where is their left-handed? I can actually specify it by just asking for it because it's an index. So if I ask for male left, it should give me an error. There is no male left. Yay. Errors are making sense. And instead I can ask for male right. And that'll pull at 122 out of that multi-index thing. You can also, again, you can tell which columns are indices because they're closer to the line and they're in bold. And it's trying its best to print nicely. So you can sort of see there's a little space here. If you can imagine an Excel spreadsheet, that's like that merge cell kind of idea.
So did people understand why it failed the first time before?
Yeah.
This is actually a really tricky thing about pandas, I think, is that there's this method called set index, which you would think would edit the object you're calling it up, but it doesn't. Instead, it returns a copy of the object that has changed the index. It's kind of a misnomer, like usually if a function is called set index, it would change the object. But in pandas, they almost never change the object itself because they kind of assume that you've got copies of that object all over the place, and you don't want to change it out from underneath some other person's using it. So that's why you almost always have to say your data frame is equal to your data frame dot something. Change it.
And in comments, I mistakenly assumed that the method set index would do that for me, what is known as in place, meaning that I don't have to have it return something. The object underneath has been modified already. I sort of mistook the set to be in place, fair enough. But actually in pandas or in other particular libraries, you actually need to have it return to another variable or replace the variable you were doing. So there are some things like NumPy random set seed, I think, will set a seed for you and you don't need it to return a variable, but it will have randomly generated a seed for a random, for like a random number generator. And you don't need to have that return anything for you. So there are ways to sort of figure this out. There are also, is there another function you know off the top of your head in NumPy or pandas that's like, usually there's always an argument that says in place, true or false.
Another, you mean another not in place function?
Yeah.
Oh, there's tons.
They're everywhere.
Yeah. I mean, a general rule of thumb is if a function has set in it, like it's set index, usually that means it's in place. Pandas is just violating the standard, basically. And it's Pandas pretty much always does that. Pandas will almost always return something instead of modifying it.
And you'll sort of see, I found one. Drop NA is a very good one. You can do it, they literally expose an argument that says in place. Do it in place or not, true or false. Let's actually do that. This is a great moment. So I know I have NAs in my original data frame. Look at that. So let me also give a bit more space. df.drop NA in place equals true. So if I print the df the second time, I'll do the head again. If I just run this, I didn't have to assign that data frame back into itself to overwrite it. It does it in place. I'm also going to very much maximize, I'll get to your question in a second. I will maximize my ability to rerun that load CSV cell. So I don't do that twice. And then I'll sort of do another cell, copy, paste, and instead of in place false, if I run this, nothing will have happened because it didn't perform it in place. I would have to instead do this, reassign it, have it have an output, and then it'll be overwritten. And then you can sort of produce a NAD-dropped data frame. For the most part, if something is unexpected, this happens to me, as you can literally tell, quite commonly. I'll forget these things. But most of the times I do expect the word set or like reset to be an in-place kind of operation. You'll also encounter, as we go on to other lectures throughout the course, the word fit. Dot fit is an in-place method call. You won't think it is, but sometimes it is. Or something like estimate, it'll be an in-place. It's sort of like convention that it is that way. Most packages will do it that way, but not always, I've found. So sometimes you want to just read that doc real quick, just make sure. I saw the hand, yes.
Yeah, I remember the in place is kind of, is the analogy in R, like the pipe operator?
Yeah, it is. It is. So either you do it now or then you have it output at the end of the thing.
Yeah.
Yeah. Good analogy for our users in the room. I think we're at time, basically. There is more stuff that was used. This used to be 2 lectures, but most people know a bit of coding now, so we've done only 1. But there is also a visualization notebook in the curriculum. Please feel free to go do it or go look through it. The 2 packages it talks about is matplotlib. As the name suggests, someone really wanted MATLAB plotting inside Python. There you go. Most of the function names almost match 1-to-1, which I found really funny when I first learned about it. So if you know anything in MATLAB, it works in here. But also if you know how to plot in any other coding language, it's the same kind of idea. Most of the plotting languages, in terms of the basic plotting languages, is sort of like, right, you plot one thing, you add a thing on top of it. It is an additive layer on top of the image. Please feel free to give it a look. For our tidyverse users, we have another package called Seaborn that I mentioned very quickly, very briefly. Let me go take a look here. We also have a very tidyverse-like call or more data-oriented call where Seaborn, usually shorthanded with SNS, specifies, hey, I want a data frame. So it's working with pandas. On my x-axis, I want to plot this particular column. On the y-axis, I want to plot this particular column. And I have a hue or I have a palette I want to specify it with. What kind of plot do I want? Bar plot? Boom. There's also that kind of way. So I would, analogy-wise, matplotlib in Python is like base plotting, like super basic plotting. You can do almost anything with matplotlib, but it is super duper basic. Seaborn's a little bit higher level abstraction. I have some organized data. I want it along the X, I want it along the Y, or I want colors. But your data does need to be organized. It can't be as free floating as just here's my vector or here's my image. Let me plot it. Don't be afraid to go look through some of the visualization libraries, matplotlib. A lot of these visualization tools have tutorials, so you have really quick examples, but more importantly, I actually tend to go towards the galleries. So galleries of matplotlib examples here. Wow, this is really old. To the new ones. There are plenty of examples of different kinds of plots that you may want to conceive of that you may not have conceived of. Oh, do I want a bar chart with gradients in the background? Dang, why do you have this? I guess why not? The answer is definitely why not. So you have these, people have plenty of really Googleable, like I want a really fancy pansy brain floating in 3D space. We got you. You'll have an example there. Seaborn also has galleries for this too. Example galleries are a little bit fancier looking. Seaborn has also a very clear aesthetic. So if you want to match their kind of aesthetic or their kind of formatting, right? If you're into kerning or if you're into like letter spacing, they have their own kind of aesthetic built in. Here are some examples. They do really great heat maps. They do really great correlation plots, density plots like this in 2D. Again, look at the galleries, look at what people post online. You might also want to do some interactive plots. I don't really recommend digging too deeply into Plotly, but if you want to have plots that do little bar charts and things like this, so like, woo, I want to look at California. I want to look at Bakersfield. And then you can zoom in and you can click on things. Interactive plots or figures. Plotly is an option. There are other options. Plotly is not the world's most friendliest package, as I have found, but does work. So here are many plotting options for you. Give a look at their gallery. Ask us questions if you want to. Otherwise, it's time.